Hello, brothers, and a very warm welcome to all the engineers tuning in right now. I'm a UPW operations expert, and in today's explainer, we are going to master exactly how to adjust sodium metabisulfite dosing pumps based on your free chlorine and ORP results. I want you to treat this as a definitive hands-on training session. We're going to take this slow, deliberate, and step-by-step. Why? Because the ultra-pure water filtration systems we operate demand absolute precision. If you are out there installing and operating UPW pure water systems, what I'm about to share with you is absolutely critical for protecting your plant. Okay, let's dive into this. Here is our roadmap for the explainer so you know exactly what practical procedures we're covering. 1. SMBS system and principles. 2. Why SMBS matters and mistakes. 3. Step-by-step pump adjustment. And 4, essential safety and takeaways.
All right, kicking things off with Section 1, SMBS System and Principles. Before we touch a single dial, we have to understand our baseline layout.
Now picture your pre-treatment PNID layout for a second. You've got your source water flowing right through the multimedia filters, and we use chlorine there to control biological growth, right? But here is a terrifying fact for us plant operators. Our polyamide TFCRO membranes are incredibly sensitive. We're talking permanent damage from just 0.05 to zero point 0.1 parts per million of chlorine. In literally a matter of minutes, oxidation physically snaps those membrane bonds, leading to massive salt passage. We absolutely must neutralize every single drop before it hits the RO. And that brings us to our primary defense mechanism, sodium metabisulfite, or SMBS. It's an economical, highly effective chemical-reducing agent. When we dissolve SMBS in water, it forms sodium bisulfite. The chemistry here is straightforward, but honestly, it's beautiful. The bisulfite reacts with that yellow-green hypochlorous acid, the chlorine, and safely neutralizes it straight into harmless chloride and sulfate. Let's talk about the exact numbers. Theoretically, we need about 1.34 to 1.46 ppm of SMBS to neutralize exactly 1 ppm of free chlorine. That's just the fundamental stoichiometry. However, in our real-world UPW operations, you know we can't just aim for the theoretical minimum. To guarantee a complete reaction and ensure absolute safety for those expensive RO membranes, you should always aim for a 10 to 20% excess dose. So, to deliver that precise dose, we rely on our dosing skid. I want you to visualize the physical components you check on your daily rounds. You've got the white cylindrical tank holding a 5 to 10% solution by weight. And remember, it's got to be sealed to prevent air oxidation. Then we have the PVC diaphragm metering pump with its digital LED display. The volume it pumps really depends on 2 mechanical factors, the stroke length percentage and the strokes per minute, or SPM. Finally, the chemical travels through the injection quill right into the waterline, protected by your Y strainer and an anti-siphon valve. Moving right along to Section 2, why SMBs matters and mistakes. Now, what's really interesting about this next part is the cost of getting it wrong. Listen, I need to be completely clear with you here. Membrane damage from chlorine is entirely irreversible. If chlorine touches that RO, those polyamide bonds are physically snapped. You're going to instantly see your salt passage graph skyrocketing and your rejection rates completely plummeting. And worst of all, there is zero chance of a CIP, a clean-in-place procedure, fixing it. You can't recover an oxidized membrane. Imagine the difference between a pristine membrane and a wrinkled, damaged one. The cost of replacement and plant downtime is just massive. So, operating the SMBS pump is a total tightrope walk. You might be thinking, hey, I'll just crank the pump up to maximum just to be safe. But you really can't do that. If you dose too little, a sudden spike in municipal chlorine, maybe after a heavy rain or pipe flushing, is going to instantly destroy your RO membranes. But on the flip side, if you dose too much, the excess bisulfite actually turns into an all-you-can-eat buffet for bacteria. That leads to severe biofouling in the RO. Extreme overdosing can even drop the pH locally and generate dangerous sulfur dioxide gas. It's a delicate balance. Which brings us to a huge, critical operational mistake, relying solely on ORP. Look, ORP measures the total oxidation reduction potential of the water. Now, if your ORP meter shows a red 350 millivolts warning, yeah, that is a high-risk warning. But a low ORP does not guarantee zero chlorine. Other reducing agents can easily mask the reading, giving you a totally false sense of safety. That is exactly why the pink DPD color test is our absolute gold standard. It specifically measures free chlorine. You have to use DPD to verify, brothers. All right, we are now entering the core hands-on procedure. Section 3, step-by-step pump adjustment.
This is exactly what you'll use on your very next shift. Let's mentally map this entire task out from start to finish. It's a strict 6-step sequence. Step 0 is preparation. Step 1 is measure the baseline. Step 2 is calculate the dose. Step 3 is adjust the pump. Step 4 is remeasure and verify. And Step 5 is log the data. Let's break these down nice and slow. Step 0 begins before you even touch a dial. Put on your full PPE. Pop open the tank lid and visually verify that your chemical level is above 25% and that it isn't cloudy. Okay, Step 1. Draw your water sample into a clean plastic bottle. But crucially, make sure your sampling point is 10 to 20 pipe diameters downstream from the injection quill. We need to be sure the chemical has fully mixed. Run your pink DPD test to check free chlorine, and simultaneously check your ORP probe in a beaker. Remember, under 200 millivolts is generally your safe zone, but always rely on your DPD. Now for Step 2, calculating your actual current dose. Let's break down the math here. We need 3 variables. Q water is your RO feed flow in cubic meters per hour. Q dose is your pump's actual output in liters per hour. And C tank is the concentration of your SMBS solution. The formula is beautifully simple. Dose equals Q dose multiplied by C tank divided by Q water. We do this math to ensure our operational dose sits safely within that 2 to 5 ppm target range. Once you've got your dose figured out, we reach Step 3, adjusting the pump. If your DPD shows any free chlorine at all, you must physically turn the stroke length knob or increase the SPM on the pump. But listen to me carefully here. Only adjust in increments of 5 to 10%. Never jump more than 30% at a single time. And honestly, most importantly, you have got to wait out the chemical lag time. It takes about 5 to 15 minutes for the water to travel and the chemical reaction to actually stabilize. You've got to be patient. After you wait out that lag time, we close the loop with Steps 4 and 5. Remeasure the water. You are looking for a perfectly clear DPD test, exactly 0.00 ppm free chlorine. Check your SCADA trend screens for that safe, flat green line. And finally, log everything on your tablet or your logbook. Record the time, the exact chlorine and ORP values, your tank percentage, your pump settings, and the flow. Diligent logging is literally what saves us during future troubleshooting.
All right, let's transition to the final wrap-up. Section 4, Essential Safety and Takeaways. Because strict rule adherence protects the plant, and more importantly, it protects you. Treat SMBS with the utmost respect, guys. It is a powerful chemical. Always ensure your dosing area is well ventilated. When you're handling the raw powder or the concentrated liquid, wear your full PPE, goggles, thick rubber gloves, and a gas mask. I literally cannot stress this next point enough. Absolutely never, ever allow SMBS to mix with acid. Doing so instantly releases highly toxic sulfur dioxide gas, which can be lethal. If you do get bisulfite on your skin or in your eyes, execute a 15-minute flush at the safety wash station immediately, no exceptions. To rapidly summarize our best practices, here are 6 key takeaways to remember every time you walk past those black and yellow warning pipes. 1. ARO handles 0 chlorine. 2. Always verify your ORP readings with a DPD test. 3. Never just set and forget the pump. Remember, municipal water changes daily. 4. Do not overdose, or you're going to feed biofouling bacteria. 5. Always ensure you inject before a static mixer for proper chemical blending. And 6. Log every single parameter diligently. I want to leave you with this final, uncompromising thought. Free chlorine before RO must be 0 ppm. That is an immutable rule. Master your pump adjustments, respect the chemistry, and log your data. But seriously, ask yourself this before your very next shift. If your municipal feed suddenly spiked with chlorine right now, is your chemical lag time short enough to save your membranes? Think about it. Stay safe out there, brothers.